cognitive services regular speech to text. So that is how I thought like we'll do something else. And last year, I think that is how I met Lalit in AZConf last year. So we were part of the same conference which I was talking. So yeah, this is something about me. I work as a data engineer at Rakuten, and previously I was working with Cognizant. And today, so these are some of the very basic stuff that we have used to build this game. So Python for general programming and Pygame. So it is live and you can try it out. I'll let you know like how it is used. And this is something that I wanted to build. And the one thing that it is not here is WebAssembly, which is kind of a niche right now. It is kind of a Web3 world, a Web2 world's Web3 or blockchain if you call it as, since it is very in the nascent stage that none of the adoption is happening or it has happened. It is very at the initial stage of WebAssembly, if you know. So I'll talk about what is WebAssembly and what you can, how you can leverage it and why it is being used and why it is popular and it will become popular in few years. So that is one of the good things I wanted to learn. So I thought I'll combine all these things together and put up something. So that is helpful. And that is one thing that I wanted to do. Let's say if you want to learn something, you try to build something on top of it. So that is one thing. It is easier and good to do if you are not able to or not if you don't want to work out something and you want to build something just for fun, you can definitely try it out. And BigBag is again which is the WebAssembly package. So WebAssembly is kind of a compiler which compiles any of the source code. Let's say you write in Rust or you write in Python, you write in C. So WebAssembly is kind of a runtime engine where you can put any of your WebAssembly code into it and it runs. So normally how a Python code executes is where it has its own compiling VM, which is running when you start an interpreter. And whatever code that you put, it is converted into bytecode. If you see in the Python, once it compiles, you would see the pyc.pyc extension, which is a bytecode form of Python, which runs in that VM. So what we are trying to do is we are trying to compile that same Python code into something else, which can run in a VM, which is meant for running all the other. So it is like a bridging the gap between different languages, where you can compile it with WebAssembly so that any of the language which is converted to WebAssembly can be run on all the modern browsers. I think Safari, it is not working. I have tried with Safari, but that is one place it is not working yet. But all the other three browsers I have tested, Mozilla Firefox, Chrome, and Edge, for all the three supports WebAssembly and it is working. But unfortunately, only for Safari, I can't make it work in the mobile part, but other things are working. And GitHub Actions to make my life easier. So when you don't want to deploy it, multiple times into a server, write a GitHub action, which will do your work when you push a code or merge. So that is pretty much standard stuff. And the last part is cognitive service. So why cognitive service? I have used, so there are some offline packages as well. So you don't want to pay for Azure, let's say. You are thinking in that angle where you don't have to pay anything to transcribe text. So what we are doing is we are trying to transcribe speech to text. That is a very simple thing. And the offline WebAssembly, the offline part of translating is not working that fast and it is not giving accurate results. So I moved on to this using Azure. So this is one thing that I'll show you in the demo part. So this is some kind of an architecture diagram which represents what I have built. So where you have a web interface and then where you have Python code and you have Azure Speech Service. So your Python code basically calls Azure Speech Service. It keeps on running so that it transcribes all the text. So how we map it back to the game? So there are two ways of doing it. One is where you can directly build the Azure cognitive services built right into the game. Let's say you have a game module and then you put the WebAssembly inside the game or your Azure cognitive service inside the game. But the problem there is, let's say the game has multiple moving components where the game has to, since Python is like where Python executes line by line and it is interpreted. So you have a lot of restriction where you can't do multiprocessing, threading. You can do it in one way, but it is very difficult to accomplish. So what I try to do is try to use async IO. It is more like multitasking, multiprocessing, but that is totally different what do you call the ship that I'll show you. So any of you heard Space Invaders ever before? Space Invaders, folks? Nobody. Oh, okay. Yeah, but okay. So that is the basic game scratch that I built. So where you move the ship and shoot. So in the traditional gameplay, that option is not there, where you can only move or shoot. So those are the only two options. Or you can keep shooting. So you can't basically like do two things at the same time. So that is one thing that even this game that I built, it is not working yet. So where you can keep on moving. So modern games support that. But the older games, when you play the arcade games and all, you can just only do one thing at a time. Where you can either move the ship or shoot or do something else. So there are only one option to do it. But again, when you use Async IO, where you can wait for something to complete, I'll show you a custom wrapper that I wrote for shooting something, where you will tell only one word and then it kind of keep shooting everything, so that you don't have to kind of press the button each and every time. So again, WebAssembly, this is converted in GitHub Actions itself. So it is no more you're compiling something in your local machine, deploying it. So it is like a Python code where you push it to the GitHub and then it compiles into WebAssembly and directly it runs on GitHub pages. So there's no hosting cost. There's no overhead of you trying to do anything. You just need to push your code. Great. Some of the challenges, I think I've spoke about all these initially, but I'll touch upon this as well while we are actually playing the game itself. So issues with Async IO. So there are two things that I wanted to cover where you have to, where Azure Speech Service is like a one-time thing where you would wait for something. Let's say if I'm talking, I'll talk for 5 seconds and then I'll wait and then the transcribe of the 5 seconds comes back to me. So I have to wait for that 5 second interval, 5 second interval to get the transcript back, the transcripted text back. So that is one thing that Async IO kind of does better. You can also try with multiprocessing, multi-threading, but Async IO does a better job at it. And there is a kind of slight support with Python SDK of Azure Speech Service, where you can wait until that function completes so that your Python code can do something else. Waiting for the response from Azure Cognitive Services. Let's say you press something on your keyboard, it is not getting interpreted or it is not getting utilized. So your press will be executed after. I'll show you in the demo where you will see that execution. It starts executing, but you can't move anything. So it is like one-time action that the compiler stops. You can't do anything apart from executing the code in your Python file. So that is one part, and that is still in progress. I am still working on a fix for that, where you can do multiple things at the same time. And the game logic and this, I think this was a fork from one of the repos. So the game logic, I don't want to build the game all again. So it is like a basic fork from one of the packages. I'll show you the name if you want to. You can fork and play around with. So this is basically how it looks. So it is a very typical, the exact match, or I would say at least 90% exact match of the original game. So this you can see in multiple screens, but the mobile version, you can see the screen and the game loads in Chrome, but you are not able to click. So the click interface is not yet, I think I'm not sure how to implement it again, but the click interface is not working, the touch interface is not working. So if you have a keyboard and mouse, it is working fine. Even if your, let's say you connect your Bluetooth keyboard with your phone and then do stuff, it is working. But the touch interface is not yet, it is not yet working in iPhone and Android, I think, and both with Chrome and Safari. So this is one of the GitHub actions that we have. So I'll show you. It is very simple line. I was like thinking it has to be a lot of lines you have to compile and you have to push across. And then I came across this pickback where there is a GitHub action specified. It is like just 2 lines you have to write in the GitHub actions YAML file, and then it does the job. So you know more. I thought initially I'll deploy it in Azure Functions where you have to pay when everybody uses it, right? So I think GitHub Pages, it is free. I'm not sure on the rate limiting, but yeah, again, at least it is free to try out. So I'll show you things in action. So hold on. So this basically is the speech service. I think I tried it last night if the demo is working or not. It was working. So So these are some of the calls that I made. It is around 22. So we'll try to spin up the game and we would see if the call gets higher or lower. So at the back end, what is happening is when you see network, so you can see what exactly it is happening, what it is getting from the website. So what you have here is a JSON and an APK file, which is the WebAssembly compiled version of the Python code, which can directly run on any browser. And this is what is getting generated when you compile with Pickback to WebAssembly. So this is one of the files that is getting generated, and we have 3 files. One is the basic HTML layout. That also I'll show you in the GitHub repo. So there are only 3 files are getting generated. One is, so this is just the 2-line code that I told you about. So you have to install, and then you have to build that Python file, whichever game that you're trying to run. So if it is not visible, I'll zoom it out. So only 2 things: when you install the library itself, and then you try to build. So these are just simple 2 lines, and this is one step of doing it, and the second step is pushing it to GitHub pages. So this is very simple. I thought it is very complicated to do such kind of things where you can deploy automatically and you have to compile it whenever you push. So it was a very simple fix that I found. So you can definitely try it out. So these are the 3 files. One, we have the PNG, which is shown over here. So this is the PNG file. If you're not sending anything, it automatically has a library image, which it adds by default. And this is the HTML page, which is getting generated. So the interesting part about WebAssembly, I'll talk about this a little, and then we'll go to the demo. So where you can write native, so how you're accessing DOM with JavaScript, you can directly access the DOM with Python code. So that was one of the interesting things that I learned while doing this. So WebAssembly is not just where you kind of call the JavaScript APIs to do stuff. So you can directly manipulate the DOM with pure Python code, no more JavaScript. You can directly run it, but it is slow. When you see the game was loading a bit slower, so it basically downloads the APK and all that stuff happens in the background. It has to compile and it has to run. But basically the idea is here to how you can make your Python code run in browsers. So native Python code. So there is no JavaScript. I have not written in a single line JavaScript code. This entire HTML is getting generated for me. And I have not written any. So all these things are little new to me as well, and it is a field where it is evolving, where WebAssembly and other packages are getting developed to compile different Rust and Python, C, C++, C Sharp, and all these once it comes available and live. So I think most people will start using their own language and not migrate to JavaScript just for building servers and UI. So you no more need React or Vue or any kind of JavaScript framework to be able to build a UI and then play around with it. You can, if you're a Python developer and you're struggling with that, there are a few packages out there which can make UI when you have Python code. One example is Streamlit. How many of you are familiar with Streamlit? Dash. Okay. So that is a way of doing it, but again, it generates HTML code at the backend where you write a button click and then on change all these functions you call. But I think it is features are very limited in Streamlit, where I think we have a in-house tool which kind of works with Streamlit, but we are also exploring other tools which can do it in a better way, since Streamlit is very slow. When you load it, when you do something and it refreshes the entire page. Let's say if you're doing API calls or if you're loading a huge CSV file onto the browser to show some reports, So it is very slow, and every time it is not just the slowness of the actual Python, it is also the fact that it reloads the entire page for some reason. I think the framework community is still trying to address that. But still, that one problem that we have is it reloads the entire page. So it is basically reloading the entire stuff. So the entire Python code for that particular page kind of reloads. So that is one issue that we had, but we had some fixes, but still we are able to use cache, and we are able to store the CSV file locally in your browser so that you don't have to refetch every time with pandas. So that is a simple fix, but again, still it is work in progress. So all these code, if you can say, I have not even gone through the entire code, but basically you can see. So Emscripten is the compiling part. So let's say you have GCC, which compiles your C++ and C code. So it is similar to where Emscripten is compiling your Python code into WebAssembly. It is a bytecode, so you can't read it actually, but where you can convert into bytecode and kind of runs in the WebAssembly VM. So I think Docker has some kind of a support for Wasm for now. But still it is also in a nascent phase in a beta release where you can play around with it. But yeah, truly powerful if you're just doing Python programming and you don't want to use any other framework for doing something else. Definitely try out this. It is very easy to do. It is not magic, by the way. There are frameworks like Streamlit which does some magic at the back end, which you may not know. Like let's say there's a button getting created, you see st dot button, and then you create a button. So that is all you write, and then converts that code into HTML. But there's a magic on how it does and what is exactly doing. But this is not magic. You directly interact with your web components, any component, for example. That is one easier part of doing it. So you can definitely try it out. Highly recommend. This is going to be the next step for web, in Web 2 at least. So Web 3 has another update. But Web 2, if you want to step up your game, let's say you want to develop an UI basically. So I'm very bad at developing UI. So I started using Power Automate, Power Apps to kind of reduce my UI workload. So if you want to, I can do it on React. I've done it in the past, but it is very time consuming to build up a React application and put it on Docker, run it across. So Power Apps and Power Automate kind of gave me a way to kind of go away from React and using HTML at all, where you can drag and drop things. And then I can manually control to when the button is clicked, and I can call an Azure function which can do something and give the result back. And I can store something in database. SharePoint list is a very good use of database, which I'm using. I'm not sure if that is the right use case, but I have been using the SharePoint as a database, SharePoint's list to be specific, as a database for a long time. So that is one of the feedbacks that I got from one of the hackathon judges, that I was using Cosmos DB for some reason, since I have some credits to do that in Azure. So that is one benefit of being a Microsoft certified trainer. You get $100 credit for Azure services, which you can use across. And I was using Cosmos DB, and the judge was like, why do you need Cosmos DB for doing such a simple thing? And then he started explaining you can use SharePoint list. So that is one thing that I started using, and it is very good and very easy to build. So you can build a UI in, let's say, one day. You can make a production ready UI with backend within one day. So it is very easy to do such things in a very short time. So what we'll do is put this game aside and then start the Python code. So basically you can move and then shoot. This is one fix that I made last night. So what you do is you start the recognizer, and then it has started. So when you say start, it kind of recognizes it has started. So let's say so whatever I say, it is left. This is the problem. So when I say left, and then it is trying to capture the remaining voice, it is waiting for some time. So still the transcription is done. This is very slow, to be really honest. And then I have configured few of the functions where you can definitely try it out. Let's say rapid fire. thing, it kind of does that automatically. And then you can say move left. I think it can move. So this is like a latency. There is a latency between the time that you say. This is another thing that I build. How many of you have seen Real Steel? Yes. So I was able to kind of do a similar thing with deep real-time conversion, where it is very fast. Once I say left, it kind of moves the ball. So that is one thing. It was very cool to build. That is why I won the grand prize as well. But still, where you are able to kind of do it real time, it is very difficult. So there is network latency, there is your Python code executing, and then there is a backend which serves you the kind of text. So all these latency comes up, and then it is very difficult. I'm not sure. The movie is like frictional though, where it kind of Jackman says all the commands, uppercut, dodge, all that commands. It is like more real time, where you see the movie. It is very fantastic movie to watch, and where it kind of does it everything in real time. So once he says, it kind of does. So it is like you think something and it does. So shadow mode is something I'm still working on. So that is still in progress. I think for next hackathon I'll put that away. So that is a good movie to watch if you're not watching any movies or not series like me. Definite recommendation to watch that movie. And the point of watching that movie is like how much science and how much technology goes into the play. There is no more where someone talks in a microphone and the bot does something. So you can't replicate that in real life. So it is very difficult and very hard. But if someone does try to do that similar thing in real life, it will be very cool. So as someone who works in technology and who wants to try out new things, so if you watch such kind of movies, you will get an inspiration to do something which is maybe it is just a copy of it. I would agree that it is a copy. So if I have not seen the movie, I may not have tried that out in the first place. But still, I was able to do it. But this is one of the things that kind of all the hackathons that I participate every week. Every week, mostly I go like 10 hours, 10 plus hours. So even I don't work that hard for my office, but still I would say that Saturdays and Sundays are dedicated for that. So if you work for a goal, like let's say developers have the power to build anything you want now. So with the coming of ChatGPT and all these things, I think it is transcribing all this. But still, so the developers have the power to build anything you want now. With ChatGPTs, no LLM models, it is going to get stronger and stronger, more powerful. More features will be added. Now we are just doing text. Maybe if you think something and it can give you the result. So that is something that I wanted to do, but it is not done yet. I have seen a demo where people use the brain waves to identify what you are thinking. Where you so instead of asking DALL-E to create this image, let's say you think of a flying cat image on your head, and then it generates that image. Now, how cool is that? Like, let's say if you think like it is very easy to do since they identify the pattern of how the brain thinks. So let's say the user thinks no such thing, and then there is let's say it is a waves, right? So you can match the waves. So let's say this is this. Then if you think it is like a regular what do you call classification or some model which is supervised. Sorry.
Some process which is actively.
Yes, it is more a supervised. It is not even unsupervised, semi-supervised. It is supervised. You know this. If this is the wave and this is what the user is thinking, you train that model, and then it is very simple. So once you get the wave pattern from any of the device, I'm not sure of the device name, but once you get that wave, you can directly match with what the user was thinking. So that is one of the cool things that you can build. Definitely a good idea to try out for any of the hackathons that you guys are participating. But this is something that is a good time as a developers to try out different things, not just conventional way of doing a web page, display something, do a database CRUD operation, build something in UI. Try out something different like this, where you have the Python code, you still learn something, of course, where you know how the game works, why multiple things are happening in the game, and why a traditional Python can't do it. So if you see in the game has so there's moves and there's a bullet coming out, and you can still move